For question number 32, part A, we have to show that the function f defined from real to real number by f of x is equal to 2x upon 1 plus x square is neither 1, 1 nor odd. So this is question number 32, and this function is defined from set of real to real number. That is, domain is a real number and codomain is also the real number. And this function is defined by 2x upon 1 plus x square. Now, let's try to check its validity for 1, 1. And for that, we are going to consider two elements, x1 and x2 for domain R. And we will show that if their images are equal, then these two numbers are not the different ones, but these two are also same. For the same image, these two are also same, then the function becomes 1 and 1, which shows that for every x there is a unique y. So fx1 according to this function would be 2x1 upon 1 plus x1 square. This is 2x2 upon 1 plus x2 the whole square. Okay, 2 and 2 gets cancelled. Let's cross multiply this, which gives me x1 plus x1 into x2 square is equal to x2 plus x2 into x1 square. And rearranging them gives me this is x1 x2 square negative x2 x1 square is equal to 0. So x1 minus x2, let's take negative x1 x2 out, so this becomes positive, which gives me x1 minus x2 is equal to 0. So x1 minus x2 is common. We are now left with 1 minus x1 into x2 is equal to 0. So either x1 minus x2 is equal to 0, which shows that x1 is equal to x2. So in this case, it's 1, 1, but it should also satisfy this. So this gives me that it's x1 into x2 is equal to 1. So if x1 into x2, the product of two numbers is 1, that means these two numbers are not same. That is x1 is not equal to x2. So that means function is not 1, 1. Now let's check its eligibility for onto function. And for onto function, every y should have x according to this relation. So our function is f of x is equal to 2x upon 1 plus x square. F of x means this is y, so y is equal to 2x upon 1 plus x square. And we have to check for every y there should be an x. So if I cross multiply this, which gives me y plus yx square is equal to 2x, and I can write it as this is x square y or yx square plus y minus 2x is equal to 0. This is a sort of quadratic equation, and we can find out the value of x. So this is minus b, that is our quadratic equation is yx square minus 2x plus y is equal to 0. Let's put this in the standard form. So this is yx square minus 2x plus y is equal to 0. Here a is equal to y, b is equal to negative 2, and c is equal to y. Okay, so x is equal to minus b plus minus root of b square minus 4ac by 2a, quadratic formula, which gives me 2 plus minus root of b square, which is 4, minus 4 into y upon 2a. So this is the value of x. Now this is 4 minus 4y square by 12. Now the value of x, this is real only if this value is real. So for x to be real, under root of 4 minus 4y square should be greater than or equal to 0. So we can write for x to be real number, this 4 minus 4y square should be greater than equal to 0, because if this is negative, then we have x as imaginary numbers. So which gives me minus 4y square, and y square is greater than equal to 1, which gives me y is greater than equal to negative 1 but less than equal to 1. So this is our range. So our range is restricted to minus 1 to 1, and this does not belong to codomain, which was our real numbers. So that means that function is not odd. And it's also asked in the question, what should find set A so that the given function f r to a becomes an onto function. So the set A for which this function becomes onto function. So this set A, it should be for onto function, this set A should be negative 1 to 1. For all values for between minus 1 and 1, including negative 1 and 1, there is always a pre-image here, x. That is for every value of y in this set, there is always an x and this function becomes odd. So our answer for the last one, that for the function to become onto, for the given function to become onto a should be equal to, our function should be onto a should be equal to negative 1 to 2. Okay.